Hi there, I'm Anna Marie Larson, and today I will be debunking the movies Interstellar and Gravity. So just a disclaimer, I still think that everyone should support sci-fi movies. They're beautifully curated, and even though they may not always be 100% accurate, it is still something worth watching. So for our first movie, before I dive in to debunking scenes, let's talk about what is going on for those of you who may have never seen it. For Interstellar, in the Earth's future, the planet has become almost uninhabitable. NASA physicists is working on plans to transport humankind to a new home via wormholes and black holes. But first, he sends a group of NASA researchers and a NASA pilot through wormholes and across the galaxy to find planets viable of supporting human life. So before dissecting the scenes I'll debunk, let's start off with some information that you guys should know. Black holes. So let's talk about black holes. What is a black hole? So a black hole is an object whose gravity is so strong that not even light can escape it. And now we have to talk about our three types: stellar, intermediate, and supermassive. A stellar black hole is a black hole formed by the gravitational collapse of a star, which is true for all black holes. The mass of a stellar black hole ranges from around 5 to several tens of solar masses, and they're also known as collapsars. An intermediate mass black hole is estimated to have a mass between 100 and 1,000 solar masses. It is unheard of that one single star could have created such a large black hole, so astronomers have a theory that this is due to the black hole either consuming so much material that it grew exponentially, or that two black holes merged together. Supermassive black holes appear in the center of most galaxies, to include our own, the Milky Way. They range pretty heavy, between millions to billions of solar masses, and this could be in credit to their location. There's so much dust and gas and so many stars floating nearby that the black hole could consume all this material in such a short time period, or again, the merge of hundreds of black holes. The photos that I have here in the video is the first image ever captured of a supermassive black hole. And I want to play this video just to get a brief image of what it is.
The Event Horizon Telescope is a project that we've been working on for many, many years to take the first picture of a black hole, and we've done it. It seems impossible. How do you take a picture of something that's shrouded by nature's ultimate cloaking device? What happens is the black hole's gravity is so intense that all the gas and dust that's attracted to it has to get into increasingly smaller and smaller volumes. And just as your hands heat up when you rub them together through friction, all that gas heats up to hundreds of billions of degrees. Everything around the black hole is ultra-luminous. In fact, central black holes in the centers of galaxies can outshine all the starlight from all the stars in the entire galaxy. And that provides this three-dimensional flashlight around the geometry that's warped by the black hole itself. So as all that light is lensed around the black hole onto what we call the last photon orbit, it forms a ring. And that ring, the shape and size of it, fall right out from Einstein's field equations.
It required creating an array of telescopes that spread over the entire globe, acting together to synthesize an Earth-sized telescope. And to be able to peer down to the black hole itself required doing this at higher frequencies than had ever been achieved before. This required recording petabytes of data.
Those recordings have to be brought back together to a central location where they're compared. We do all the timing afterwards in a supercomputer. And all that technology really has come about in the past 10 to 5 years or so.
So to have something here where we're able to see in a picture something that's been predicted now for about 100 years, and immediately connect it to a theory and immediately make constraints that no one's ever been able to make before. I mean, that is just, it's incredible.
So how cool is that? This is our first ever image of a black hole, and I wanted to show this video to depict how hard of a process and how thorough and how kind of perfect everything had to be in order for this image to be captured. So let's talk about more on the black holes and its layers. So first off, let's start with the singularity, which is located at the very center of the black hole. This is where all the matter and energy have collapsed into a region of infinite density. Next, we have the event horizon. This is the radius around the singularity where matter and energy cannot escape. It's essentially the point of no return. The innermost stable orbit is the inner edge of the accretion disk, where material can safely orbit without reaching the event horizon. And lastly, the accretion disk, a disk of superheated gas and dust that rolls around a black hole at immense speed, producing electromagnetic radiation, which helps reveal a black hole's location. So essentially, in the previous picture, what you were seeing was the accretion disk and the black hole in the center. So here are two movie scenes from Interstellar that I'll be debunking. The first scene that I will play for you is when Cooper and his crew fly through a wormhole.
Don't work here. We're passing through the bulk, space beyond our 3 dimensions. All you can do is record and observe. What is that?
It's them.
Distorting space-time. Don't!
The next scene that I want to debunk is when Cooper ejects himself from his spacecraft and falls into a black hole and ends up in an alternate dimension. So yeah, Cooper ends up in an alternate dimension of his past. Early on in the movie, and if you've seen this before, you'll kind of realize that this is the moment where his daughter was sitting in the room and these books just kind of fell off the shelf, and this kind of explains how that happened. Okay, so for debunking the scene, let's first talk about what would most probably happen if entering a black hole. I do want to note that when Cooper ejected himself from his spacecraft, and then you kind of just see like this formation of what appears to be a black hole with no accretion disk around it, I feel like even right there, just how would you know the black hole is there? Anyways, let's start off with spaghettification. I'm going to play this video of what happened when a star crossed paths with a supermassive black hole. So in that video right there, you kind of see the accretion disk, the star being pulled in by this black hole, and it reached that point of no return. Okay, so spaghettification. What exactly is the definition of spaghettification? Spaghettification, which is sometimes referred to as the noodle effect, is the vertical stretching and horizontal compression of objects into long, thin shapes caused by extreme tidal forces. And kind of like in this picture above, I feel like that's what would have actually happened to Cooper. I feel like if a black hole could tear apart stars, then I can only imagine what it would do to the human body. So would he have actually survived that? Most likely not. Let's talk about alternate dimensions. So, are they possible? Are there multiple versions of ourselves throughout different pockets of space and time? Well, here are some theories. The infinite universe theory, or universes theory, my bad. The theory is that the shape of space-time is flat and goes on forever. This presents possibilities of many universes existing, which would result in the theory that because particles can only be put together in so many ways, that universes can start to repeat themselves. Then you have the daughter theory, the daughter universe theory. This theory revolves around the theory of how subatomic particles behave and the laws of probability. Similar to the theory of infinite universes, this suggests that our decisions are different in other universes, resulting in different lives, however, the same person. So, however, with all the theories in place that suggest for parallel universes or the multiverse, we need to consider the fact that the universe is just under 14 billion years old. So this puts limitations on the number of possibilities for particles to rearrange themselves, identical to our own world as we know it. So essentially, if Cooper survived that and landed into an alternate dimension, this would prove the theory of the infinite universe theory. However, again, very unlikely. I hope all these breakdowns we have reviewed have helped in debunking the scenes from Interstellar. So let's move on to gravity.